Okay, well, welcome to our Stanford Medicine Community of Improvement Professionals November meeting. We're really excited to continue our conversation about AI and improvement. We've got Ron Lee here. I'll introduce him in a moment. He's one of the leaders at Stanford, leading work in AI and in improvement. So I'm really excited to hear from him. And I'm excited for all of you as well. I'm recording this, as everyone knows, so that those that aren't able to make this particular hour, I recognize that a number of people do catch the recordings, hear this after the fact. So we want our community to be beyond just those that are able to make this 1 hour session throughout the week. And so whether you're listening to this or whether you're here live with us, make sure to interact with us via email, going to our SMCI website, pulling down the, you can hear the recordings there. You can also communicate. We've got a team site. We've got all kinds of ways to communicate with one another. So we really want this to be interactive, engaging. So as we do this, I really expect that you all will interact as you already have. So we're going to have, I just have one announcement, which we've already somewhat got to, but I want to make sure it gets on the recording. In just a moment, I'm going to ask Jakaria to mention something about our next month event. And then I'll introduce Ron. We'll break up into groups. Although we've got such a small group, we'll probably, if we keep this size, we'll probably keep it all together so we can discuss in the bigger group. And then as always at the end, we'll have a few minutes where we can do the I like, I wish, I wonder, where you'll all provide your feedback on what you liked about this, what you'd like more of, and then possibly opportunities for improvement that we could look to for the future. Or even things that are just the I wonder is, they could be anything. So, and you could provide feedback there. So with that, I'm going to go ahead and pass it to Jakaria briefly, and then once Jakaria is done with her announcement, I will introduce Ron.
Thank you, Ryan, and happy gratitude season to everyone. Thank you so much for joining. I'm grateful for each and every one of you, those that I work with closely, those that I'm getting ready to work with, those that I have the opportunity to engage with. So excited you're here. I want to actually give gratitude to Shalisha Grace Edwards, who is also here and has given us the inspiration for our December meeting. She has actually launched an opportunity to have discussion around this book, Multipliers, written by Liz Wiseman. And so for our December meeting, we're going to engage with phase 1 of discussion. Shalisha has sent out a doodle poll. If you are interested in taking part in it, I think Ryan will maybe share the doodle poll with our distribution list for SCIP, so that we can capture everyone's availability, and then we'll send out the date that works best for everyone. If you're not able to read the book, if you're not a Liz follower yet, you still should come so you have the opportunity to learn and glean and maybe become inspired. So Shalisha, thank you for the initiative and for getting us started off in December with a lens for leadership and collaboration and learning with each other. So we look forward to that. Thank you so much for taking the leadership role and getting us into that path.
Thanks for creating the space.
Awesome. Okay, so let's go ahead and I'd like to introduce Ron Lee. So let me give a quick bio about Ron. Ron is a clinical associate professor of medicine in the Division of Hospital Medicine and Center for Biomedical Informatics Research at Stanford University School of Medicine. As the Medical Informatics Director for Digital Health at Stanford Health Care, he provides medical and informatics direction for the health system's enterprise digital health portfolio, including expanding digital referral networks and virtual care modalities. He's also the co-founder and director of the Stanford Emerging Applications Lab, or known as SEAL, which helps clinicians and staff build ideas into novel digital products that are prototyped and tested for care delivery at Stanford Health Care. Also, I mentioned before, Ron and I had the opportunity to go through the Stanford Medicine Advanced Course in Improvement Science together, and he and I were on the same team. we got to know each other quite well and discussed things about how to integrate improvement in AI. And so I wanted him, knowing that he's got a passion for this, I asked if he would come and talk about the way he's doing that here at Stanford. So he graciously said, yes, I would love to come. And so he's prepared a deck for us to discuss. And with that, I'm going to go ahead and pass it to Ron. Thank you so much, Ron, for coming, and look forward to hearing your talk.
Thanks, Ryan. Yeah, really glad to be here. Can you hear me okay? I think my connection, I had to switch the phone audio. My connection before, I think, was not great. Well, really excited to be here. And yeah, I mean, Ryan's, I always think fondly back to, the time during our course. And I think you guys are all incredibly lucky to spend time with Ryan, like such a rich resource of really everything. So glad to be back here. So I think in that, given that we have a relatively small group, I was hoping maybe we could keep this a bit more informal. But let's actually, if okay, get to know you all and have you guys introduce yourselves. I do have a deck. Then I can make it as long as or as short as we need to. But I'm hoping, given this is a relatively small group, I think it would be actually great if we could have a discussion, if I could learn from you guys regarding how you're thinking about improvement, and then even start brainstorming how we can apply some concepts around AI into your work. How does that sound? All right. So if okay, can we just go around and maybe just do a brief intros, like name and what you guys do? I guess I'll go around the order I see on my Zoom screen. Jakaria, we've met before.
Yes.
Terry.
I'm Terry Ard, and I'm from Lucille Packard. I'm in accreditation and regulatory compliance.
Great. Elise?
Hi, Elise Baggins. I'm the Director for Operational Planning and Performance Improvement for Interventional Platform Pharmacy and Radiology on the Stanford side.
Great. Shalisha?
Hi, I'm Shalisha Edwards. I'm a performance improvement consultant. I work under Elise's team.
Sharon?
I'm Sharon Economides. I work at the Enterprise Contact Center, which is in the Office of Patient Experience in Stanford Health Care, and I'm a performance improvement project manager.
There's a project I want to talk to you about, Sharon. I'll tell you more. Maybe in that case, I might even take a slide from another talk and I'll insert it here because I think you'll be interested. Sorry, Britomar, I'm not sure if I'm pronouncing that correctly.
No, that was good. Brit is a lot easier, but I work in the interventional platform at the Stanford adult side, and I manage our onboarding program as well as digital development.
John?
Good morning, everyone. I'm John Higginbotham. I'm the Director of Corporate Operations for Stanford Medicine Partners.
And Christina?
Hi, I'm Christina Davis. I'm the Director of Nursing Quality.
Great. At SHC or Stanford Health?
At SHC, yes.
Great. Can you still see me? Because all of a sudden, I think all of your faces disappeared. It's just my Wi-Fi here is not.
Yeah, you look perfect.
All right.
We can see you. Yeah.
Okay. Well, just let me know. Just feel free to let me know if I become too blurry. Sorry, there actually is a very specific project we're doing with the ECC, Sharon, that it is an AI, and be interesting to get some performance improvement perspective on here. So I'm just actually migrating these two slides into this talk. Let me just give me 2 seconds. I'm going to copy and paste it in here. Appendix. There we go. All right. So, as Ryan mentioned, I'm a physician. So my main job is that of a physician. I see patients, although a sizable chunk of my time is spent on informatics, digital health. And I like to think myself as more of an integrator role to integrate some of the enterprise level work, strategic work regarding digital health, as well as my knowledge of technology and how AI works into what ultimately improves care and helps me do a better job and helps my colleagues do a better job taking care of patients. So I'll go ahead and jump into the deck. But I do want to keep the presentation portion shorter because I would love to have a discussion here. So you might see me jump around a bit with my slides. And I'll actually just keep it not in presentation mode. Hope you guys don't mind. All right. You guys all see my slides?
Perfect.
Great. I called this talk integrating AI into QI, and I'll say from years ago. I mean, even way before large language models and AI took off. What drew me to informatics was quality improvement. What got me into informatics was I was a resident here at Stanford, an internal medicine resident. I went through that program about, I guess, 10 years ago now. Time flies. And I didn't know anything about AI. You know, in my mind, AI was all for like computer scientists, and I wasn't a computer scientist, so it just like wasn't even on my radar. What I was into was improvement. I guess I kind of have an optimizing mindset and personality, which I guess, you know, naturally led me to quality improvement as an area that I focused on during residency. And we had a QI block. Actually, Lisa Shea, who's a hospitalist and now one of the ACQOs at SHC, she led it. She was one of my mentors at the time, and I got really into it. What was really interesting, but frankly also frustrating to me at the time, was just how many interventions required knowledge of doing something in the electronic health record. And this was before digital health was even a huge thing. This was like when alerts were cool. You know, like if you built a good alert, like that was really cool. And if you could study it, that was like really cool, right? And even now, I would argue it's still useful. It's not cool anymore, but it's still one of the, I would say, most effective interventions, depending on the problem you're solving. So so my entry point into informatics was actually QI. Like I was doing all these QI projects. I went to QI training, but I just recognized that in order for me to fully understand how to meaningfully improve systems, so many of the levers require an understanding of data and technology. And I just didn't want to passively be kind of a passive consumer of the technology, but I did want to just know more and be a better partner to the folks who are developing the technology such that I could contribute more meaningfully. And that's why I ended up doing an informatics fellowship, a clinical informatics fellowship, which is a combination of operational work, data science work. I learned a bit about AI then, you know, I had some technical skills, but a lot of it was frankly doing operational projects. Like I actually led the implementation of Volt. I don't know how many of you guys are familiar with Volt, which is the clinical communications app. So that was me, I mean, at least for the clinical side, as a fellow, which was much more work than I ever expected, and learned a ton, you know, but you kind of see, but I also often will see the gaps, you know, when we work on projects, we don't necessarily adhere to QI, PI processes. And I've always been very cognizant of that, including now as I think about how people talk about technology, novel technology in particular. You know, sometimes we skip the important part, which is what is the problem you're trying to solve, how are you actually going to improve it? I think that's the key thing. I think people are actually good about saying what the problem is, but there's that step you skip between the problem and then implementing something. It's like, what is the thinking? How do you think about breaking down the problem into the root causes, key drivers, in order to come up with a solution? So that's what I'm going to talk about today. And also, I don't know how much background you all have in AI and machine learning. I was going to start out with some slides that get into the weeds a little bit. You know, you'll see some technical stuff, but I actually truly believe that as QI professionals, as physicians, I mean, I give a similar talk to physicians who are not AI experts. I think we should all have a decent understanding of what these terms are. I mean, they're not, you don't have to have a AI PhD to know this. This is all actually in some ways common sense. But I do think having these terms in our toolkit empowers us to bring it back to our work and partner in a meaningful way. So I'm going to start with that. And then I'll go into some frameworks for how I've thought about incorporating these technologies into QI projects. And I'll give some examples. You'll see that, I mean, I can't give an AI talk now without talking about ChatGPT and large language models. So you'll see me, you know, refer to this a bit. And I think for good reason, because I truly believe that this is a pretty pivotal moment in AI. The technology certainly there was some stepwise function where it got a lot better. And I think it actually it is already becoming much more relevant to our daily work than ever before. So I assume all of you know what ChatGPT is and what it does. I just want to give you an example of how it's pretty good, even for clinical stuff. Like, this is a board question for physicians. And I'm not going to get into the details, but you can see it's like it gives a patient history, it gives data, and then it asks for an answer. This is like what a fourth-year medical student, I guess, would have a. I mean, they should answer this question correctly, but it's not the easiest question either. And this is ChatGPT's answer, and I'll say it's completely right. But not only is it correct, it gives a pretty good explanation for it. And not only does it give an explanation, it gives alternatives and the reasons why the answers are wrong. So, this stuff is real. What's going on here? What do these terms mean? Machine learning, LLMs, Gen AI, ChatGPT, right? Like, what do these terms actually mean? How are they different and similar? And then later, I'll talk about why they're so exciting now, because a lot of these things actually are not very new. So I just want to go back to a couple of basic points here, which I do think it helps me, at least, even as a non-machine learning technical, PhD level expert. I think it really helps me at least understand what I'm doing here. So we often talk about machine learning models. Well, I'll start with the question of, like, what is actually a model? A model is an estimate. I think that's really important to understand. A model is an estimate of a set of relationships between data. And the most common, the simplest model that we probably are all somewhat familiar with is a line. So we probably all learned the equation for a line: y equals beta x plus, or mx plus b. I think we are often taught that. M being the slope, b being the intercept. Like, I think these are right. And so what that is it's a model, it's an estimate, it's a mathematical relationship that estimates some kind of relationship between data points. And you can see that on the left-hand side, you have all these data points. They don't actually form a line. But in order for us to understand how these data relate to each other, we have to have some way of making sense, right? So we're going to draw a line through it. And then there's an equation, and then there's an error. Okay, so that's what a model is. It's an estimate. If anyone tells you, I have a model of something, what they're saying is they have an estimate, a way of estimating a relationship between data. So what's a machine learning model? Well, we can make models that are not, like, humans create models all the time, right? Like, we create mental models of things that we kind of understand, but we need some way to extrapolate. So we will make up a model based on our knowledge, our heuristics. Well, it turns out that computers can build models too. And if you think about how a line is drawn through this data, I guess as a human being, I could kind of like eye it, right? If I look at this data, I could probably just draw a line through these points and just draw a line that I think is closest to all of these points. Like, I can do that manually based on my visualization and my understanding of what a line looks like. Well, it turns out a computer can do that automatically, and there are algorithms that allow them to do it. So an algorithm is actually there's a different meaning than model. I know we use it interchangeably, but they're actually very different. A model is the estimate. An algorithm, I think of as more like the strategy that you use to get that estimate, that model. So I might have an algorithm that says, hey, I'm just going to draw a line and make sure that it doesn't touch any of the actual points, but it's like closest to all of them. Like, that's, I guess, an algorithm for me. Well, a computer can have an algorithm too, using data, and it'll kind of do the same thing. And and the algorithm that all machine learning models use is something called gradient descent. And I won't go into what that is, but I just want to show you that that's how it works. So even if you're training a neural net, what the computer is doing is it's following a set of strategies to minimize some type of cost function so that you can draw a line where the distance between the actual data points and the line is minimized. So you can imagine a computer can do that. Like, it just follows a series of steps and it'll spit out some line, and that's what it is. So that's an algorithm. So an algorithm is a strategy that a computer uses to create a model. That's all there is to it. That's how ChatGPT works. It's a much more complex model and much more complex algorithms. So this is a computer following a set of strategies to minimize some type of error. Well, it gets a little more complicated because obviously a line isn't good enough to estimate most relationships. So the type of model that most modern AI systems use is something called a neural network, which is meant to actually mimic how the human brain works. The idea is that you create this thing called a neuron, when in air quotes. And in many ways, it actually works very similar to how like a linear model works. You have all these inputs, data points, and then the computer basically adds the data together. It has these weights, which are essentially like the slopes of a line, except that instead of one slope, there might be like 4 slopes, 4 weights. And then you have some like number that it multiplies those numbers together, and it gets like some other number. Like that's it. It just does some math, and then it takes like a set of numbers inputs. It has some formula in there that calculates another number, which is an output. And that's the output of a model, which is similar to how a neuron works. Like, right, you have electrical signals that go into your dendrites, and then your axons, and then you fire, and then it goes to your dendrites. Did I get that wrong? I always forget. I think it's the other way around. Anyway, but it's like you have signals that go in and out, right? Well, the idea is that a single neuron is not very smart. It literally is just doing addition. But if you have like a billion neurons together, then the idea is like you can actually start creating performing very complex mathematical functions that can fit. Just imagine instead of just a straight line, that's actually a very squiggly line with many dimensions that can actually fit the data really well. And that's what a neural network is. And what can neural networks do? Or just AI in general can do? I think of AI as, and this actually becomes important as we talk about how this relates to QI. I think it's very important to be very intentional about understanding what the AI is doing. Like, what are the tasks that the AI can do better than, let's say, a human being? Because then you start to think about what types of key drivers can, AI enable based on your knowledge of what those tasks are. I think of 3 categories of tasks that AI can perform. One is classification, which is basically just classifying one object from another. So on the right-hand side, you see a bunch of pictures. There's like dogs and fried chicken. Now, we can do a pretty good job classifying that based on our knowledge of what dogs and fried chicken look like, but AI can do that too. It deconstructs all these pictures into pixels, which are essentially data points, like numbers, and then you can train some model. It's probably not going to be a line, but some type of model that can differentiate the fried chicken from the dog. That's basically it. AI can predict numbers, so predict like stock prices, housing prices, so regression. That's another task. And then finally, now it's becoming more popular, AI can actually generate data from scratch. So you basically give it some data, and then like a prompt, for example, and then it generates like this whole new data set that looks like a picture or maybe like a block of text, which is how ChatGPT works. So classification, classifying 2 things into separate categories, regression, predicting new data points that can happen in the future based on prior data, or generation, generating pictures, generating text based on some type of data you give it. Those are 3 types of things that AI can do pretty well and much more quickly and reliably, right? So then that's where those are the capabilities that you now have at your disposal if you want to improve some kind of system. I'm going to skip a couple of these things here because I don't think we need to go into exactly how large language models work, but I will tell you, okay, so like what's so exciting now? I mean, everyone talks about AI, but clearly there's something happened. What happened exactly? And especially this buzz about large language models, because language models, I'll tell you, have been around for a long time, like decades. So it's not new. And even AI, like neural networks, have been around for decades too. Well, the difference is that the models have become a lot bigger, like exponentially bigger. And then we've seen that increase in size has this profound effect on how accurate these models are. So here you can see on the x-axis you have years. So starting in 2017, these models are tiny. And by when I say large, what I mean is the number of parameters. So for example, sorry, 1 second, I think I might be getting kicked out. I'm okay. What was I going to say? Yeah, so the number of parameters is basically like the number of variables. So like, y equals mx plus b. So that's like a 1 variable model. So you can see here, ChatGPT, GPT-3 is 107 billion. And it's not quite, I mean, because you don't have, there are other types of variables or parameters other than just variables, but it's about the same. So just imagine you have an equation with 170 billion variables. That's kind of like what I mean by size. And you can see how it's gone up by a lot. So that's what happened. It's just like these models got a lot bigger, and at some point around 2021, OpenAI realized that, wow, if we just made this model a lot bigger, it just starts performing amazingly well. Like that's what happened. And something that people say is they display what's called emergent properties, where the computations occur, you might have some predictions, but then if you just have so many of them happen at once, you have these outputs that you couldn't even predict. Like you wouldn't even think that they would be possible, unless you step back and looked at how they perform. So I always like to use this graphic here to show what emergent properties are. You have a flocks of birds. Like individually, they don't really know what they're doing, but then somehow collectively they create something that is profound. So a couple of just takeaways, my opinions really, but not just really my opinions. I think the opinions of the field is that these models will get a lot better. We're kind of at an arms race now, and people are worried about that, but it's happening. The cat's out of the bag. And the reason is that there's a lot of data. There's a lot more compute now, and mostly they're incentives. Like all these businesses are all incentivized to do more. Google, Amazon, they're incentivized for more and more people to use their cloud services. They're going to do everything they can to make AI more easily trainable and usable on their cloud. Companies are all going to want to use it because they don't want the other company, their competitors, to have it and not them. And of course, the builders of these models are going to want to build better models because that's how they're going to make money. So, and the governments, right? So everyone is going to be incentivized to do more. And I don't think we can stop it. It's just going to happen. So I think at this point, we have to be aware that it's going to get, there's a lot more activity. The mode of production is shifting. So before, if you want to do AI, you had to be either like an AI engineer, or you might have to work at a Google or Stanford. But now anyone can have access to the best AI in the world. You just have to pay OpenAI a couple of cents per token, and now you have access to one of the most sophisticated AI engines. They're very different than before. People know how to do it now. So you don't actually need to know any AI to use AI. You just have to have some very rudimentary software engineering skills to use APIs, and there you go, you're an AI company or an AI group. I think there's something about language that enables very high fidelity dynamic information exchange. So there is something special about being able to chat with an AI system that's very different from just getting an output, some number or prediction, right? I think the interaction between humans and AI will accelerate. Before, I think even if you have a really accurate AI classification model, frankly, for the average person, they don't really care. They don't really know how to interact with it. Whereas now you can talk with it, and anyone can talk with AI now. And you just think about how many, it's just like an exponentially higher number of interactions that humans will now have with AI. And that I think will have all sorts of downstream consequences. And of course, we're seeing this already. You just have applications and services that are enabled by AI that will just be embedded into the industries. And I think that will change society for the better, or maybe for the worse, but it'll change. There are certainly limitations and risks, and this is very specific to large language models. It's that, I think at this point, there was a bit of a shock factor, I think, in the beginning where people really thought, man, are these things alive? I think now we're pretty sure they're not alive, and they don't really think or know anything either. All they do is put words together, but they sound like they know, right? I mean, ultimately, it doesn't even matter if they know or not, or they're thinking or not, they sound like they do. So the ultimate effect they will have is going to be due to the fact that they sound like they know what they're talking about. And then you can easily create applications and personas that use AI that exacerbate misinformation, biases, other, I would say, very negative social impacts. Destruction of society, I think you've probably read about this now in the news. Everyone's worried about this. And then finally, the AI may not actually be aligned with our values. I mean, this is a concern. Because these AI models are so powerful now, we kind of assume that we can control them, but we can't. I mean, we don't even know how it works in the back end. So there's a meme that's circulating around AI circles, and and this is true. I think this actually reflects what's happening. You have ChatGPT, right? I mean, I don't know. I assume many of you have used ChatGPT. It sounds decent. It sounds like a nice person for the most part. Well, the only reason why it's nice is that it uses this process called reinforcement learning and feedback, where you have, it's just the AI actually is very capable of generating all sorts of things, including very, very not nice things. It's capable of creating that. It's just that they engineered the surface to sound nice. but behind it, you have no idea what's happening. We just did a bit of engineering to have the actual outputs sound like something that most people, or at least the people who tested the system, found acceptable. So I don't know. When I first saw this, I kind of freaked me out. It still freaks me out, and but this is what the AI engineers at OpenAI, at Google, all these companies, they're joking about this because it's true. And I just think that we should all be aware that that's what's happening. All right, so I'm going to pause first. Well, let me actually just, I'm going to keep going because I do want to get through some of this stuff, and then I'll pause. So I'm going to just pivot away from AI. This is just like learning about AI to how is it actually relevant to QI. And I'm going to skip a couple of slides here and stop talking about AI just for 5 minutes. What do we why are we even doing, what are we doing here, right? Like why do we get jobs as physicians, as performance improvement consultants, as administrators? Like, we all want to improve some kind of outcome because we want to improve some outcome for a given problem. That's what we all do. It's just the problem sets are different depending on what job we have, but ultimately we just want to improve an outcome. I think we all recognize that between the problem and the outcome, there's this gray cloud of healthcare delivery, and everything is super complex. I don't think I need to tell this group that healthcare is complex. So what's in this complexity? And again, I might be preaching to the choir here, but I think we can probably break down this complexity into people, processes, and technologies. I think the whole premise of QI is that things are mediated by systems. So we can't just convince someone to change their behavior, or have one person do something, or deploy one technology and it magically works. That doesn't work that way. Everything is mediated by complex processes that interact with the people in these processes, and now with technology is influencing everything. So this is what's in this gray cloud. And I took this slide directly from, I think, ACES or SELF. So I imagine maybe most of all of you probably have seen this slide before. And the idea is this is a complex adaptive system we're dealing with here. And the way we change it is we have to understand that things are not linear. If we increase some stress, some external change, we have to be humble about how we can't actually control what happens because there are people, independent individuals, who are in the system. So we need a way to deploy small tests of change and be strategic about how we use technology to do so. So what is technology? We talk about technology all the time, especially at Stanford. What do we actually mean by that? And how do we think about how that influences this complex system? Well, I think number one, we should be aware that technology will perturb the system. That's just a fact. Whether it's a good thing or a bad thing, we don't know, but it will change the system in some way, and we probably won't know how it changes the system. So new technology is the same thing as any external stimuli into a complex system. Well, let's break down what digital technology actually is. Well, digital technology, at least in my definition, is essentially just information and some user interface that changes in user behavior. That's what it is, right? Information is the active ingredient of a digital technology. So if you think about, if you're I think some of you guys are in the intervention platform, you probably deal with devices all the time. So in that case, the active ingredient is probably the physical, if you have a bovie in the OR, that device, that's the thing that you need, right? The bovie or the scalpel. Or if you have an MRI machine, it's the scanner. Well, for digital technology, it's the information. It's the information that's produced by either AI or it might just be some database that is theoretically useful to somebody. And then we have a way of presenting that information that could then be useful to many people, or maybe another system that we think could maybe change the system for the better. So that's my breakdown of what digital technology is. Information plus some type of user experience. And then, of course, the user themselves. We talk a lot about how LLMs can be used to improve healthcare, and this is my framework. I think of the LLM as basically just a better way of generating the information, right? That we now, so instead of having to ask people to write down stuff, we can have AI do it. Or instead of having to look up things from guidelines or use those methods, we can just have an AI generate the information that theoretically is better, more accurate, or at least more efficiently generated. So we have that piece figured out. But you notice we don't have any of the other things figured out. We still need to figure out the user experience. We still have to figure out the user and how we engage with them. And of course, everything else, all these processes you haven't even touched. That's where QI comes in. All the AI is going to do is be better at giving you information. We have to figure out the rest. And the rest is really what mediates the outcome. And that is, in my mind, the opportunity space. So when people think about innovation with AI, often we focus so much on just the information generation, the AI model, But in reality, if we want to improve healthcare, we got to think about the entire space here, because that's actually what we have to work on to improve the outcome. And again, I'll just reiterate, I think QI, or process improvement, that's where we all live here, right? This is all here. And a couple of things that I think we need to do as an organization is we have to build enough slack in the system. I mean, this is a situation where we don't know what we don't know. So if we need to be able to have an ability to perform small tests of change and empower local units, learn from what's happening. Again, I'm preaching to the choir here, but I think this is the idea. Like, if we talk about AI in healthcare, I think we do have to apply the principles of QI to make this work. Otherwise, best case scenario won't work. Worst case scenario, it'll do harm. I don't know if I have time to go through an example here. Maybe I'll just go through, let's see here. You know what, let me skip to this slide. And I do actually want to talk about this other project that sorry, I forgot your names, was working with the ECC, Sharon, you might be interested in, and I'm happy to go through another project if you guys want. I like this. So this is taken straight from the improvement guide by Langley, which again, many of you probably are familiar with. It's like one of those foundational textbooks for process improvement. And towards the end, there's a page that lists a bunch of what they're called change concepts. And these are all just like, common sense things. But I think this is I think, I'm not an improvement professional, but I think these are like supposed to be the types of things that you incorporate into systems to make them better. Well, the question I think that we should ask is, given those capabilities I talked about earlier, prediction, classification, generation, given that we think about how digital products are essentially information that's created by those tasks using AI, but knowing that the rest of the system still needs to be changed, then what are those, like, how can those capabilities, or maybe one way to think about which types of these change concepts do we need in an ideal system that we can create that right now just isn't possible because of some barrier? Maybe we want to have, give people access to information. Maybe we want to give the entire patient population access to some information. But the problem is that we just don't have nearly enough people, educators or nurses or physicians, to generate that information. Like, we just can't do that. If we could, then we have a perfect system. We know the key drivers, we know how that can mediate the outcome, we just can't do it. Well, now you can, or we might, because we have the ability for AI to generate information. So that's the thinking, I think, I want you guys to use. It's like, you have your projects ready, you have your key drivers, you have your change concepts. Think about what's not possible now, and then ask, like, well, can those 3 AI tasks make these change concepts possible? Here's one problem we're looking at now, just in digital health, SHC. So I work on the digital health team, and our job is to figure out how do we create new care and business models, care model and business model innovations using digital tools. And the concept here is you have these traditional brick and mortar driven care models where the patient has to come all the way to the hospital, get checked out, leave. We just think that there are better ways to do this. And then we can do that enabled by digital interactions using video or asynchronous interactions. But I do think that there are ways in order to make these interactions possible at scale, can we use classification, prediction, generation with AI to make these models possible? So that's something that I think about quite a bit, and we're working on. I do want to just talk about one project we're doing with the ECC. This is through a group that I run, the Stanford Emerging Applications Lab. So I don't know if this is actually your team, Sharon, but we're working with Sharon Onofre, Sylvia Ramirez on the referrals team. And this was like a grassroots skunkworks thing. It just kind of happened. We worked with Eamon Lago, who was on the rev cycle of TDS. And basically, what we did was we wanted to look at a better way to prioritize enterprise or prioritize referrals faxed over to the referrals team. And this is the cover sheet that is being used by all these referring providers. And the current state is they just all get into the same queue because you have to manually sort through them. And even if the referring provider checks off urgent, based on our conversations with the team, that there's nothing we can do about it because they just all go into the same queue. So it's a pain point. And then we worked with the team and our team, because we have an engineering team as well. We basically built an AI solution. So we thought the problem was there are too many, you have delays because of too many referrals and the inability to separate out. So then we thought, well, that's a classification problem, right? Like, what if we could classify the urgent versus non-urgent referrals much more easily without the need for a person to sort through all of them, which is possible with AI. And then can that improve the system? So this is the solution. So we basically created a new folder on their software, and it just like routes the ones with checkboxes or check marks in the urgent checkbox. It gets routed into this urgent folder. We've now processed more than 167,000 faxes since the pilot inception, and it's been working pretty well. So at first there wasn't a huge difference. So on the bottom you have the timelines. The January, end of December was the pilot initiation. On the y-axis, you have the number of minutes it took to process the referral, which is basically when the fax comes into the ECC, and then when they finish creating the order, the epic order that gets routed to the schedulers. So initially, there was a difference. I mean, it was the ones that were routed to the urgent folder, they were completed on average 45 minutes, less than an hour. And the non-urgent was about 900 minutes, but still same day. But over time, you can see that difference went up by a lot. So most recently, there was 155x difference. So it took 5 days for them to be able to go through, your typical non-urgent referral. But for the referrals routed to this right here, this urgent folder, it's still an hour. And it really helps them because they really want to to process urgent referrals on the same day. It seems like that was something they really wanted to do. And without the system, it was just really hard because they just need more people. I think there are staffing challenges. Now, despite having staffing challenges, it still works. I mean, for the most part, at least the urgent referrals that go to this folder, they can easily process it with the same day. And it's it's something that they really like using. So I just think it's a good example of how we had to start with the problem, think about the task, and then create the system that ultimately is mediating an outcome. So I'm going to stop there, and hopefully we'll have some time for discussion.
Wow, that was awesome. So Ron, I love how you incorporated so many of the different learnings that you've had over the years into that deck. That was really cool. I could actually see remember where all of those came from, and that you pulled them all together in one
lecture, which ACES lecture came from. Yep. No,
that's cool. I mean, that's really neat that you were able to do that. I think that was spectacular. And the improvement guide, which is great. If anyone wants to refer to that, by the way, here's the book, the improvement guide, and it's what he was referring to as the change concept on page 359. I put that in the chat. It's excellent tool for coming up with ideas. Ron, I wanted to let you know we did go through ChatGPT earlier this summer, in the summer of this year, on talking about generating ideas in improvement projects. So exactly what you presented, we did present that concept. So if any of you want to revisit that, go back and listen to the recording on that. It's really pretty interesting. It touches on that. I'm going to stop for a second, see if there's any thoughts, questions, comments for Ron.
No, go ahead. Go ahead, Terry.
Thank you, Ron. That was an excellent presentation, especially for someone like myself who knows nothing about AI. I did have a question on the information that's coming in, and maybe you could approach it from like a Stanford perspective, not from a ChatGPT. But is there any way let's say we decide we have bad information and we don't like what we have in there and we wanted to clean it up. Is there any way that you can clean up like that whole mass of information that's that the AI is based on? Or like, is that the whole concept of it, is that you need to keep all of it, and because that's the foundation, right?
You mean the data that the AI is trained on,
right?
Or the data that AI is using?
That information, generated. Yeah, exactly. The data that it's built on.
The data that it's using to generate the predictions. Yeah. Well, in an ideal world, all the data will be perfect, right? In an ideal, all our ICD codes are going to be perfectly accurate, and all our notes are going to perfectly capture, what's going on. But yeah, I think there are efforts. I mean, there are actually plenty of efforts. Maybe some of you are involved in them, where we try to improve documentation, or have nurses do more to document what's going on flow sheets. Like, I think that's kind of like, I think what we're trying to do. But knowing that usually that almost always increases burden on the provider, and no one wants to document for the sake of documenting. So there's going to be an inherent limitation. And in some ways, the AI models are just need to deal with that. And there is always this sense of garbage in, garbage out, which is true. If you have bad data, the AI is not going to work. I think what has been exciting though about ChatGPT and large language models is that, so that AI is trained on just everything. They ingested everything on the internet, which of course includes a ton of bad data, but they were able to show that it's still, I mean, you've used ChatGPT, like it's not horrible, right? Like it's still okay, and it could be better, I'm sure. And there are people looking at how to align the ChatGPT type model with like your own data. Like there are ways to do that. I guess the key point here is the AI is getting good enough such that you don't need to have the best data. It can't be really bad data, but it could be messy, and the AI is able to learn from that.
Okay, thanks.
So the last example, great presentation. Sorry, Ron. You just always knock it out of the park. And I'm a little ADD-ish, but I literally was glued the whole time. And Terry, like you, I've tried to log on to GPT. It tells me, oh, you have to wait or whatever, you have to pay. So I'm just as bad as you. But the ECC example brought me almost triggered me a little bit, because we can use AI to improve the systems. So in the case where the referrals were taking too long, the urgent ones, they solved the problem of making sure that they can get those done quickly. But then the non-urgent started taking longer and longer and longer. And so my question is, you used classification, but there's also, I think you said, regression and generative. Is there a way when you're building the model or trying to figure out the improvement to also think about the balancing measures, the unintended consequences? So you does it do that for you too? I'm just curious how you build that in, so you can see it coming.
No, I think that'd be your job. I think that's why you need a process. So no, I mean, the AI is not, well, you could, I guess you theoretically could. I mean, you could imagine you could, if you find the right balancing metric and then you get the data, I mean, and then you could somehow use that metric to automatically retune the model. Like you could do that. I think the problem is that I just don't think the people building models are going to be nearly sophisticated enough in understanding what those metrics mean and how to use them. So I mean, eventually maybe you could have a fully automated system where the AI is actively learning from the perturbations of the system and changing itself. Like maybe at some future state, that can be the case, but I'll tell you right now, it's not possible. Even with most advanced AI, I mean, you're going to need a team like yours to, first of all, even understand that there is a balancing metric. I mean, you'd be surprised. People in technology, they don't necessarily think that. They're like, oh, well, this works. What should I worry about? I don't think they necessarily think about, oh, well, maybe there's something else that will get worse in the meantime. So that's the work that needs to be done. And I'll admit, this project didn't have that because we didn't have a PI. This was just kind of a skunkworks thing that we did, from the ground up, and we didn't even know if it would work at first, but it was like a proof of concept. And frankly, we're actually actively looking to figure out how can we off-ramp this so that we get it, we can, given that actually, I think we've proven out that it could be really impactful, we want to kind of hand it off in a way that allows it to get more of that attention and support, because it's such an important problem for the enterprise, right? Like how do we improve referral or specialty access? And we've shown that at least this piece of technology, this classification task deployed at that particular key driver could make an impact. But to your point, we need to actually do more work to understand, well, what is actually happening to the system? And I have to admit, I don't know. The reason why the gap has increased is, from what we've heard, was because there are fewer people who could process these referrals. So in the past, they were able to do it. They were able to do all the referrals within a day, but now they can't. Whereas with our system, they can still at least process the same day referral or the urgent referrals within an hour. So that's what the difference is.
What I like about it is that when you think about AI and how big and massive it can be, this is a small footprint, if you will, right? A small issue that you can wrap your head around it and see results, right? And so it allows us to then, from that plateau, to think about other things that can be connected, right? And so then this is what you're referring to from a people standpoint. We can make it even better as time goes on by incorporating other aspects. Versus having this big, massive, problem we're trying to solve and you can't, right? And then you get swamped with all the weed type pathways you go down.
Yeah, that's exactly right. I think our approach, us as in SEAL, the group I run, it is very much the approach of let's just get into the ground. Let's get on the ground, especially when we're dealing with things we don't quite understand. I mean, if we have a technology that we just understand really well, then there is a role for this top-down, it's just like there's a predictable way to use the technology and centralize and whatnot. But I think maybe this is what you're saying, John, is that a lot of times we just don't know what we are even doing yet. And then in order to de-risk it and solve the right problems, we have to get to the level, like the 100-foot level, not the 5,000, 10,000, 50,000 foot level. Because then just nothing ever happens. People just start talking and we're not, so we want to get to the ground, get to where the problem is, get to where the people are, and let's figure it out. And then eventually when we learn enough, then we want to be able to, scale it in a more, enterprise level way.
Awesome. Ron, this has been incredible. We only have 4 minutes left, so I do want to get to the final close and give people a chance to give feedback. Thank you. This was incredible. Really, really appreciate it. Ron, can you get me, after this, get me a link to SEAL so I can provide that in, so that people can
I can
reach
send you
out
the
if
slides
they
as
have
well if
questions.
people are interested.
Yeah, that would be great. I'll share that with everyone. Also, I wanted everyone to know, I put it in the chat, a couple things. Our Black Belt course that starts February of 2024 is now open for applications. We the last couple years we've been maxed out and actually had to have a waiting list. So I want to make sure that you all hear about it. If you know people or if you're interested, please get your application in soon because it's already filling up. Also, if you would like to, please provide your feedback. I put the link for the mural where we do I like, I wish, I wonder. If you would go in there, provide your feedback, what you liked, what you like more of, what you wonder of what we could talk about in the future. I would love to hear your feedback. So that's open. You don't have to do it right this second, but if you have the time, go ahead and give that feedback right this second. If you don't and would like to go back later today, feel free because it's available. It also has a bio on Ron as well, so you can read more about him. Wonderful. So thank you so very much. Oh, Sharon already put the link in there. Great. Thanks, Sharon. And then I'll get the slides to everybody. Have a wonderful day, wonderful weekend, and Thanksgiving next week. If you're taking time off, hopefully you enjoy time with your family or loved ones or whoever you're going to be with. Enjoy it. And we will see you hopefully at our fan club or book club, I guess, whatever we're calling it. Our Liz Wiseman fan club group next month. So thanks, everybody. I'll talk to you later.
Thank you.
Bye.
Yeah.
Yeah.